So in tonight's video, we're going to finish section 1.7 on absolute value equations and inequalities, and this will be the last section on the test. So we'll just be testing on 1.5, 1.6, and 1.7. So in the previous video, we talked about absolute value equations, and one of the main things we talked about with absolute value equations is that you can get two solutions from every absolute value equation, right? Because you can be 5 away from 0 to the right and 5 away from 0 to the left on a number line. So this leads into absolute value inequalities because since absolute value implies two solutions, solving absolute value inequalities will be similar to solving compound inequalities. If an inequality uses the less than or equal to, and these symbols point to the variable in the solution uses and. If an inequality uses greater than or equal to, and these symbols point to the variable in the solution uses or. So if you see a greater than, think or. If you see less than, think and. So let's look at how this exactly works out. So in the first example we want to look at, we just have an absolute value equation right here. Okay, so it says absolute value of x is equal to 15. And we said in the last video that what that means is that we have some x values, whatever they are, that are 15 spaces away from 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so if I move 15 away to the right, this is a positive 15. And if I move 15 away to the left, this is a negative 15. Another way to think of it is that you have a positive value and a negative value of your whatever's on the right. So you have x equals positive 15 and x equals negative 15. This also applies to absolute value inequalities. So the first one we're going to look at says that absolute value of x is greater than 15. So we said earlier that if you see greater than, then you have absolute value inequality that deals with it like a compound inequality that has the or. So first thing I'm going to do is I'm going to write this as two separate inequalities, just like with any other compound. So the first one I'm going to write is x has to be greater than 15. And the second one I'm going to write x less than negative 15. Okay, and so what this does is it says we want all values, because what this inequality says here is that we want all values of x such that the distance is larger than 15. So you're looking at numbers like 15, 16, 17, 18, 19, 20, okay? And you're also looking at negative 16, negative 17, negative 18, negative 19, negative 20, all right? So that's what we're really doing here. So when I graph this on a number line, I have 0, negative 15, and 15. I put an open circle at 15, negative 15, and it's everything less than that, and I put an open circle at 15, and it's everything greater than that. Let's look at another example. This time it says absolute value of x is less than or equal to 7. So since we have a less than sign, we're looking at an and statement for the inequality. Okay. And again, the first thing I'm going to do is I'm going to write this as two separate inequalities. The first one is x less than or equal to 7. The second one is x greater than or equal to negative 7. So notice every time I write the negative of my number, 7 in this case, but just the number in general, I always flip the sign. It's just a good habit to get into because that's what you're going to be doing every time. Okay, so I have x has to be less than or equal to 7 and x has to be greater than or equal to negative 7. So I'm expecting to see some overlap in my graph. Seven, 4, 5, 6, 7. Okay, so the first one on the left, it says x less than or equal to 7. So I put a closed circle on 7, and it's everything less than or equal to. Then at for the second one, it says x greater than or equal to negative 7. So put a closed circle at negative 7, and it's everything greater than or equal to that. So then I want all of the overlap in between, so that is right through here. Okay, so I'm going to redraw my number line. 0, 7, -7, close circle at -7, close circle at 7, and then a line connecting the two dots in between. Okay, and so the way you kind of read this, which is different than the other one, is that what you're looking for in this inequality is all values of x where the distance is less than or equal to 7. So you're looking at 7, 6, 5, 4. You're also looking at -7, -6, -5, -4. Okay? Let's look at some examples that are a bit more complicated. So for 28, we're given the inequality -2 is greater than the absolute value of x minus 8. So before I figure out if I have an and statement or an or statement for the inequality, I'm going to first just get the absolute value by itself on one side. So I'm going to add 8 to both sides. And I get 6 is greater than absolute value of x. So we have a less than sign pointing towards my variable. So that means I'm looking at an and statement here. Okay? So what I'm going to do from here is I'm going to break it up into two separate inequalities. So I've got 6 greater than x, and I've also got -6 less than x. Okay? So I'm going to then graph this on a number line. So what I have is an open circle at -6, and it's everything greater than -6. So it goes to my right. And then I have also an open circle at 6, but now it's everything less than 6, so it's everything to the left. And then what we're really looking for is just the overlap. So my number line will have an open circle at 6, an open circle at -6, and then a line connecting the two in between. Let's look at another one. It says absolute value of x plus 2.4 is less than 3.6. So again, the first thing I'm going to do before I figure out if I have an and inequality versus an or inequality is I'm going to subtract 2.4 from both sides. So the absolute value of x is less than 1.2. From here, I see that I have a less than symbol pointing towards my variable. So that means I have an and statement again. Okay, and then I'm going to break it up into two separate inequalities. So I'm going to have x less than 1.2 and x greater than -1.2. So again, remember, every time I write the negative value, I always flip the sign. From here, I graph my inequality. Since this is an and statement, I expect to see a connection between my two numbers. So I have -1.2, 0, 1.2, an open circle at each, and then a line connecting the two in the middle. Like so. Okay? Next we have 32, which says the absolute value of 2x minus 5 is less than 9. So in the previous examples, we would simplify by adding or subtracting a number from both sides to get the absolute value by itself. However, in 32, the absolute value is already by itself. So we're going to separate this right away into two separate inequalities. So before I do that, I'm going to tell myself, do I have an and inequality and or? Since I have a less than symbol pointing towards my variable right here, I know that I have an and compound inequality. So I'm going to break this up into two separate inequalities. I have 2x minus 5 is less than 9. And I also have 2x minus 5 is greater than -9. I'm going to solve the inequality on the left first. So I'm going to add 5 to both sides. I get 2x is less than 14. Divide both sides by 2, so x is less than 7. On the right-hand inequality, I'm going to again start off by adding 5 to both sides. I get 2x is greater than -4. Then I'm going to divide both sides by 2, so x must be greater than -2. Remember, I only flip the sign if I'm putting a negative value for the absolute value inequality, or I'm dividing by a negative. Other than that, I do not flip that sign. okay? So my solution is all values of x greater than -2, but less than 7. So again, I'm going to have an open circle at my 2 values, and then a line connecting them in between. (34) is even more complicated than 32 because now it says we have -2 times the absolute value of 2x plus 4 plus 10 must be greater than -6. So the first thing I'm going to do is just like in the first 2 examples on this slide. So I'm going to subtract 10 from both sides. So I get -2 times the absolute value of 2x plus 4 is greater than -16. From here, I'm going to divide both sides by -2. When you divide by negative, you flip the sign. So I have absolute value of 2x plus 4 is less than 8. Okay, and I do all of these steps first because I want to get that absolute value by itself. So now that I have the absolute value alone, I am going to then split it up into 2 separate inequalities. Before I do this, I need to identify, do I have an and inequality or an or inequality? Looking at the signs, it is less than right here. So it says less than 8. That means I have an and inequality. Okay, so my first inequality when I break it up is going to be 2x plus 4 is less than 8. My second inequality is going to be 2x plus 4 greater than -8. From here, I'm going to start off by solving the inequality on the left. So I'm going to subtract 4 from both sides. 2x is less than 4, and then divide both sides by 2. So I get x less than 2. I'm going to then start solving the inequality on the right. So again, I'm going to start off by subtracting 4 from both sides. 2x is greater than -12. Then I'm going to divide both sides by 2. So I get x greater than -6. So I'm looking at all values of x that are between -6 and 2, non-inclusive. So I put a -6, 0, 2, open circle on the -6 and 2, and then a line connecting them in between. Let's look at one more just for good measure, okay? So this time it says the absolute value of x minus 2 plus 8 is greater than or equal to 10. So the first thing I'm going to do is I'm going to try and isolate that absolute value. So I'm going to subtract 8 from both sides. So I get absolute value of x minus 2 is greater than or equal to 2. Now that I've isolated the absolute value, I'm going to then separate this into 2 different inequalities. The first one being x minus 2 is greater than or equal to 2. The second one being x minus 2 is less than or equal to -2. From here, I'm going to start by solving the inequality on the left. So I'm going to add 2 to both sides. So I get x is greater than or equal to 4. And then I'm going to solve the inequality on the right by adding 2 to both sides again. And I get x less than or equal to 0. The one thing I didn't do, silly me, was figure out, do I have an or inequality or an and compound inequality? So if I go back up to the first line before I broke it up, it says absolute value of x minus 2 greater than or equal to 2. So this means because I have a greater than or equal to here, I have an or inequality. So it is x greater than or equal to 4 or x less than or equal to 0. So now I'm going to graph this inequality. Okay, I have a closed circle at 4 and a closed circle at 0. It is everything greater than or equal to 4, so that's everything to the right of 4, and everything less than or equal to 0, so that's everything to the left of 0. Okay, so that's that graph there. And that's it, okay? So the classwork due at the end of the next class period is page 47, numbers 7, 8, 12, 27 through 33 odd, and 35 through 38 all. If you have any questions, please bring those with you to class and be prepared to ask them.